So hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 3. So in this module we will be discussing inheritance, types of inheritance and special functions like friend function, virtual functions, etc. in C++. So let us start inheritance. In this session we'll be discussing inheritance and the types of inheritance. That is what we are going to see in this session. So coming to inheritance, it is very simple. Acquiring the properties from one class to other class, or getting the properties, variables and methods, or member data and member function from one class to other class. So the class which is offering is called a superclass. The class which is receiving is called a subclass technically. So the class whose features are inherited is known as superclass or base class. The class which is getting or inherits or acquire from the other class is known as subclass or derived class. In a local word, the superclass can be called as parent class. The subclass can be called as child class. Okay. And in a real world example, the son is getting the properties of dad from dad. He is called a base class or superclass. The son is called as child class, subclass or derived class. Okay. So the capability of the class to derive the properties and characteristics from one class to other class is called inheritance. Okay. So the advantages are code reusability. Because the functions defined in base class can be reused without rewriting the code in the subclass. That is what code reusability. And it also saves the time and effort, because the code is already written in the base class or superclass. We simply inherit and we can use the same function in the subclass. So it supports reusability and saves the times and effort are the advantages. Moving on to the modes of inheritance, or visibility mode of inheritance. We are having three types: public, private, and protected. So these are the three modes of inheritance. Whether the features of the base class are privately, publicly derived, or protectedly are derived to the subclass. The three visibility mode: public, private, protected are the three visibility. In which mode you are inheriting the base class to subclass. That is what the visibility mode or modes of inheritance. So the public mode means, if you are inheriting in the public mode, means all the members of the base class are public in the derived class. Okay. While inheriting, if you are inherit in a public mode of inheritance, all the base class members become public in the derived class, or it is just as they are in the base class. That is what the public. Coming to private, if you inherit the members in a private mode, all the members of the base class become private in the subclass. Okay. So if you inherit in a private mode, all the members are inherited to the becomes private in the derived class. And third one is protected. All the public members become protected members in the derived class. So I'll show in the table, you'll understand easily. So assume that these are all the base class members: base class public, base class protected, base class private. Okay. So these are all the in which mode I am going to inherit: public mode, private, or protected. So let us see the public. If you inherit the public mode, all the public members will be public in the derived class. All the protected will be protected, and private never inherited. Okay. So it is same as the base class. Public become public, protected become protected, and private never inherited. Okay. This is the public mode of inheritance. So next one is private. We'll see private mode of inheritance. So public base class become private in derived class. Public protected in base class become private in derived class, and private never inherited. In all the modes, private member never inherited. Okay. And coming to the third one, protected, public become protected, protected become protected, and private never inherited. Okay. So these are all the base class access mode. if you're inheriting in a public mode, this will be the resulting access mode in a inheritance. Okay. So in detail, it is given here. If you want, you can refer the PPT. Public mode in a base class to derived class. So private member never inherited. Public become public, protected become protected. So this is the public mode of inheritance. So check out the base class to private mode of inheritance. So private become private, protected become private, public become private. Okay. So check out the third one, protected. So base class private become private, protected become protected, and private is never inherited actually. Public inherited as a protected. Okay. So that is what the modes of inheritance. So private never inherited to the any of the subclass or child class or derived class. Only public and protected can be inherited in the three modes. Okay. So let us discuss the types of inheritance. So there are 5 major types of inheritance. The first one is single or simple inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and the hybrid inheritance. Let us see one by one what is what. Single inheritance or simple inheritance, we are having only one base class and only one derived class. Right? So base class, this is the base class, and derived class is this one. So this is the access specifier, mode of inheritance, whether you are inheriting in a public, private, or protected. So anyone should come over here, and the base class name. Okay, this is what the single or simple inheritance. So the good example is bank account is the base class, and savings is the derived class. So savings account inherited from the bank account. The customer name, balance, account number can be used in the derived class. Single inheritance, you have to inherit in the public. This is actually class diagram, class UML diagram. So plus is public actually, plus is public. Okay. And next type is multiple inheritance. By the name itself, multiple base classes. Remember that. Multiple inheritance means multiple base classes. So A and B are the two base classes inherited to the third class C. So base class 1 defined, base class 2 is defined, and in derived class, so in a comma separated, two classes are inherited. So access in which mode is inheriting the base class, comma, mode of inheritance of the base class. For example, for this example, class C would be colon public, assuming that you are inheriting the public mode. So public A, comma, public B. So both the classes are inherited to the class C. So that is what multiple inheritance, multiple base class or multiple parent class. Okay. And next, yeah, this is the another example. From savings account and loan account, premium account is actually derived. Okay. So another real world example from the banking sector actually. Okay, so third type of inheritance is multi-level. So level, think about level, staircase, steps, multi-story building. So multi-level means level by level, like a ladder. So we are having one after another in a one by one. Okay, that is what multi-level inheritance. So class B is derived from class A, class C is derived from class B, hence from class A to B, B to C. So coming to C, through B, A also inherited to the class C. Okay. So A is a base class, B is also base class for C, derived class for A, and C is the derived class for P. Okay. And next, yeah, the syntax is given. So base class 1 is class A, base class 2 is getting from base class 1, and derived class is getting from base class 2. So you take this base class B as a base class 2. So class B, public A, class C, colon, public public B. While inheriting, no need to include the class keyword. Only class definition needs the class keyword. Okay. So next, yeah, this is the real world example of multi-level. So bank account to the loan account to the car loan account. So another simple banking example. Next inheritance is hierarchical inheritance. So hierarchy. So top will be there. from a top, the all the subclasses are getting the same. So only one top class is acting as a base class for several more than one subclass. So for B, C, D classes, only one base class. Okay, one class is inherited by the many subclasses. So syntax would be class A is inherited to class B, class C, class D. So class B public A, class C public A. So class A is inherited to the all the subclasses. Okay. And the next type is, or last type is hybrid, the combination of any above said 4 inheritances, single or multiple, multi-level, 2 or more combinations of above said from the above said inheritance can form a hybrid inheritance. So check out this. So class A is inherited to B and C. So if you remove class D, so it will be hierarchical inheritance. If you cut the class A, so from class D is getting from B and C, multiple. So here hierarchy multiple. If you cut the class C, so A, B, D, it's a multi-level. So you can have a multiple, multi-level hierarchy inheritance all together in a hybrid inheritance. Okay. So assuming the same example, class A is defined, class B and C is getting from class A. So class B is getting from A, class C is getting from A, and the class D is getting from B and C. Class D is getting from B and comma C, multiple inheritance. Okay. So that's all the types of inheritance. We discussed what the type of inheritance in this session. We'll see in detail in coming sessions. Thank you all. So hello everyone. So welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 3, Inheritance in C++. In this module, in this session, we will be discussing single and multiple inheritance. And in the last session, we discussed the introduction to inheritance and types of inheritance. Now we'll be seeing single and multiple inheritance with the example to code. Let us start with a single inheritance. So single inheritance is we are having one base class, one subclass, or one superclass, one subclass. So the class extends to the other class only. So base class is this one and derived class is this one. So colon access specifier in which mode you're inheriting. Public, private, or protected, and the base class name. So while inheriting, no need to insert the class name over here, only give the class name, no need to insert the class keyword here. Only while defining the class, you should supposed to use the class keyword for defining the class. Let us see the example. So the same example. So from the diagram, actually I'm implementing the example. So class A is a base class, class B is a derived class. So class A is a base class, class B is a derived class. So class B public, in a public mode, I'm inheriting the class A to the class B. Okay. So in a public mode, class A is inherited to the class B. Okay. So class B colon public the class A. A is inherited to the class B in a public mode, which means all the public will become public, private will become, protected will become protected, and private never inherited. For the safe side, I'm using the base class A, all the member data and member function in a public access mode for ease of understanding to avoid the difficulties. Okay, so int x is the one member data, get data is read the value from the terminal and have it. So end of the class. So class B is inheriting the class A in a public mode. All the public will be available here also. So int y and the read data are the member data and member function of the class B. So in addition to this, all the public members is copied, readily available in the class B in a public mode. Okay. So this read data is reading the y value from the terminal in the class B. So in the and show function in the class B is displaying x and y because x is in a public mode of inheritance and x is also is inherited in a class B. So in a class B, with the show function displaying the x value and y value. Even though x is belong to the class A, because of the inheritance, the x and get data is actually inherited to the public part of public mode of in a class B. So end of the class, the semicolon, in a main function, create an object for derived class. So my derived class is class B, get an object, and you can call all the methods, get data, read data, X, Y, everything is available in the class B, so that you can create an object for the derived class B, and you can call the base class function get data, read data, and show function by the derived class object obj. Okay, I think you got the how the single inheritance or simple inheritance is actually working. So this is the another real world application using banking. So here I'm not explaining what is there inside the function and the member data. I'll explain the overview. So we'll see this one. So overview. So base class name is bank account, and I'm inheriting to the savings account in a public mode. Okay. So base class attributes of name, balance, account number, and the two functions open and the display. The plus represents them in a public mode. All are in a public mode. And in derived class name is savings account. I'm inheriting the bank account in a public mode, so that all the name, all the member data, member function of the base class is actually available in the derived class, inherited to the derived class. Okay. So with the diagram and explain the outline. So base class name is bank account. So it is having member data and member function in a public access mode. Okay. And end of the base class bank account. Okay. So savings account is the derived class, colon, public, in a public mode, I'm inheriting the bank account to the savings account. So colon, public mode of inheritance, base class name is bank account. So that all the public members are readily available in the public access mode of derived class. Okay. So end of the class, and here I'm having a function, member function, and two member function, deposit and withdraw, and create an object for the derived class. Savings account is my derived class, create an object, and you can call all the methods. Open, display is copied to here, not copied, which is inherited to the derived class. So s.open, s.display, s.deposit, s.withdraw. So with the derived class object yes, you can call base class method, deposit, open, display, deposit, withdraw, and display again. Okay. So real world scenario, banking scenario, single inheritance is actually appeared here. So with the diagram, I think you can easily understand how it is happening. Okay. So next inheritance is actually multiple inheritance, multiple base classes. So more than one base class is there. So here in the example, I given two base classes. You can have as many as base classes as you want. So in a class C is inheriting from more than one base class. Okay. So base class 1, base class 2, base class 3 or 4, whatever, how many bases as you want, you can have. In a derived class, access mode, base class 1, comma, access mode, base class 2, and so on and so forth. So this is the way to inherit in a multiple inheritance. So you can have this diagram. So savings account is the base class 1, loan account is the base class 2. In savings account, I'm having a 2-member function, and say loan account, I'm having a 2-member function. So both the classes are inherited in a public mode to the premium account. So all the methods are readily available in the derived class premium account. So here also I'm not going to explain what is happening inside every function. Let me explain how the overview of the coding which is implemented using this real world example banking. Okay, two base classes, savings account and loan account. So coming to the diagram, base class 1 is savings account. So it is having some member data and member function, 2-member function, and end of the class. And the second base class is loan account. Loan account, member data, member functions. So generally we will be having member data in a protected or private, member function in a public. General way of discipline of writing code in inheritance is member data in a private or protected, member function in public part, public access mode. So here we are having a function, several functions over here. So two base classes, savings account and the loan account. So the public, coming to the diagram. So in the premium account is derived class, which is inheriting the savings account, comma, loan account. Check out this inheritance. So premium account is the derived class, colon, public base class 1, comma, public base class too. So both the classes, the base classes are inherited in a public mode. So all the public members will become public in a derived class. Protected will become private here. Okay. So you can create an object for the derived class premium account and you can call all the member functions. So open account belong to bank account. Deposit also belong to bank account, and loan, open loan is belong to loan account. Calculate EMI also belong to loan account, and show all is only function belong to the derived class. So with the base derived class object, you call all the base class functions. Okay. So you can go through the coding, what is there inside every function. So open account deposit belongs to the savings account. Open loan calculate EMI function belongs to loan account. So all the four functions are given into the premium account. So you can create an object for premium account and you can call all the methods. Show all is the function in the derived class. You can call the fifth function with the derived class object. That is what given over here. So just go through the code. I'm just explain how the inheritances happen and object creation and the function, member function invocation. So what is there inside every function? Just go through. It's a calculation only, simple statement only. Okay. So this is the example of multiple inheritance example. Okay. So that's all. End of this chapter. See you in the next chapter. Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module Inheritance in C++. In this session, we will be exploring the multi-level inheritance with the example program. Last session, we explored single and multiple inheritance with the example code, and now we'll be seeing multi-level inheritance in C++. So multi-level inheritance, one class inherits from the derived class. So class C, so here in the example, class C inherit from the already inherited class, right? So the derived class becomes a new base class for the new class. Okay, so class A serves as a base class for class B, and which is a derived class of class A, and class B is acting as a base class for class C, which is a derived class of class A. So A inherited to B, B inherited to C. So multi-level inheritance is a kind of ladder or staircase or multi-story building. So one by one, the classes are inherited to the subclasses. Multi-level inheritance. So syntax is, so base classes, so here in the example base class is A, so class A, and class B colon access mode class A, and class derived final class last derived class colon access specifier and base class 2. So this one. Okay, so that is what a multi-level inheritance syntax, and we'll see example code. So before that, we'll see the class diagram. So bank account is the base class which is inherited to the loan account, and loan account inherited to the car loan account. Okay, so bank to loan account to car loan account. So this is what multi-level inheritance. At the level 1, base class bank account is there. At level 2, bank account inherited to the loan account at level 2. At level 3, loan account is inherited to the car loan account. In turn, bank account also inherited to the car loan account. So this is the class diagram explaining the multi-level inheritance. So this is the real world example. So we will be discussing the real world example as a code. Okay. So coming back to the code, bank account is the base class, and it is bank account is having name, balance, and two member functions. So end of the bank account class. And coming to second class loan account, class loan account inheriting the bank account in a public mode. So all the public properties, member data and member function, variables and methods are inherited to the public part of or public visibility mode in the derived class loan account, which means so all the public members are available in inherited to the public part of the loan account. Okay, so in a loan account, so some protected members are there. So these member data are in a protected members, and member function open loan and calculate EMI are in the public access mode of the loan account. So bank account to loan account, so it is one level is inherited. So coming to next level, so class car loan account is inheriting the loan account in a public access mode. Again, all the public members of loan account, including the inherited public members of the bank account, both will be available in the public access mode of car loan account. So already bank account public member data member function are inherited to the public mode of public part of loan account. So together, two member function, four member function, and three member data all together inherited to the public part of the car loan account through this next level of inheritance. So in the car loan account, it's having its own member functions, open car loan and display car loan, two member functions, and end of the class. So inside the function, what is up? Just a read and doing a simple calculation and displaying the values. That is what happening in the every member function. Just go through that. And coming to the main function have to create the object for derived class. Last derived class is car loan account. So create the object for car loan account, access member functions from bank account, loan account, and car loan account. So these two are from the bank account and these two are from the loan account, and open car loan and display are belongs to the car loan account. So all the member functions, base class 1, base class 2, and current derived class, all the member functions are accessed by the car loan account derived class object by using that object. So this is how I didn't go through the line by line code, but I explained how the multi-level inheritance works with the three levels of inheritance classes. Okay, so that's the end of the multi-level inheritance. See you in the next lesson. Welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 3, Inheritance in C++. So in the current session, we will be exploring the hierarchical inheritance in C++ with the example code. And in the previous session, we discussed how the multi-level inheritance is implemented in C++ with the example code. And now we'll get into the hierarchical inheritance. Coming to the hierarchical inheritance, one class is acting as a base class for them, more than one subclass, or more than one subclass. For example, class B, C, D, for all these three derived classes, only one base class, class A. Or class A act as an apex for all the B, C, D classes. Okay, so one class is inherited to the many subclasses. So in the demo, for the explanation, I used only three classes in the derived class. You can have as many classes as you want in the derived class. More than one base class, minimum 2 or maximum n. Okay, so class A is inherited to the all the derived classes. So class B, C, D are the derived classes. Okay, let us see the syntax. So class A is the apex or common base class. Class B, class C, class D are the derived classes. So all the derived classes are inheriting the single base class B. So class B, access specifier, most probably public A. Class C, access specifier public, class A. Class D, so not given here, class D colon public A. So class A is inherited to the all the subclasses. Okay, so we'll see a simple example from the diagram. So single base class. So class A is the base class. So XY a member data, one get data function reads X and Y. So end of the class. Two member data and one member function. So that is what the properties of a class A. So class B inheriting in the public mode, class A. So class B inherits A class in public mode, and class B is having its own member function product. So all the public properties are readily available inherited to the public part of class B. Okay, and third end of the class B. Coming to third class, class C. Class C is the second derived class inheriting the A in a public mode. Then all the properties of XY get data is available in the public part of class C. Similarly, third class, which is a class D, inheriting the A class in a public mode. Again, all the public members are copied, not copied. It is available inherited to the public part of class D. In addition, with the its own function called division. So sum is doing the summation of x and y. So x and y are the members of the base class A. So because of the inheritance, xy is available for class B, class C, and class D. Okay. So end of the class. So end of each class with a semicolon. So one base class inherited to the B, C, D subclasses, 3 subclasses. Okay, coming to the main function, in order to check out the diagram, I'm having 3 base classes. So I should supposed to create 3 objects for the base classes to call it their member functions. So class B, class C, class D. For 3 classes, 3 objects supposed to be needed to be created, and the respective. So get data is the base class given to class B, and similarly for get data for class C and get data for the class D. Similarly, product is the class B, available in the class B, and sum in the class C, and division in the class D. So you can check out the code. In the class B, function is product. Class C function is sum. Class D function is division. So that is what. So obj1 is class B, obj2 is class C, sum, and obj3 is class D, division. So respective derived classes objects are used to invoke the member functions. One is inherited, get data is inherited, and the rest is their own functions from the respective base class, derived classes. So simple code explaining the hierarchical inheritance with the simple code. So with that, we're finishing the current chapter, hierarchical inheritance. Hi everyone, welcome back to the course of Essentials of Object-Oriented Design and Programming. So we are in the module Inheritance in C++. Last session we discussed about hierarchical inheritance with the example code, and in this session we'll be discussing hybrid inheritance in C++. So hybrid inheritance is the combination of any 2 inheritance which we discussed in the earlier. Maybe the combination of single, multiple, multi-level, and hierarchical. So combination of any above said, any 2 of the above said is making the hybrid inheritance. So minimum should be, it's a mix of 2 or more above said types actually. Check out this example diagram. Class A is inherited to class B and C, and class B and C inherited to the class D. So if you take the upper part A, B, C alone, ignoring the, wait a minute, yeah. So take the upper part ignoring the class D. So A only considering class A, B, C. So it is the hierarchical inheritance. So single class is inherited to the more than one base class. So that is hierarchical. So if you ignore the class A, considering the B, C, D, the lower part, so it is a multiple inheritance. So multiple base classes inherited to the class D. So hierarchical and multiple. So if you ignore C, class C, A, B, D is a multi-level inheritance. By the way, you can ignore the class B. Also, you can get the ACD as a multi-level inheritance. Right. So if you ignore C and D, it could be acting as a single inheritance. So all 4 types of inheritance can be possible in this hybrid inheritance. Okay. So let us see the syntax. Yeah, class A is the base class inherited to the class B and the class C. So refer the diagram. So class A is inherited to the class B and class C. So class B public A, and class C colon public A. So class A is inherited to the B and C. And the last one, class D is inherited from B and C. So class D, public B, comma, public C. So that is a derived class. So the same example given in the simple member function and member data. So class A is a single base class. It is having a member data x and y and get data member function. Read the x and y from the terminal, end of the class. So class A is over. Class A is inherited to B and C, right? So B and C. So coming back, class B inheriting class A in a public mode. Similarly, class C, public A. So class B and C inheriting the class A in a public access mode, which means all the public members of class A is inherited to the class B and the class C. So it is available in this public part of class B. It is also available in the public part of class C, which means for product, the X and Y values are taken from the base class A. Similarly, for some X and Y values are taken from the base class X and Y. Coming to the last class, class D. So go to the diagram. Class D is inheriting from class B and C. Multiple base classes. So class D colon public B comma public C, multiple base classes. Okay, so because of the through B and C, class A is inherited in both the classes. Through any of this way, X and Y is available in the class D. So two times actually the class A is inherited two times to the class D through one through B, one through C. So two times it is going to be inherited. So with division it needs X and Y. So it is available in the public part of class D through the B and the C. Okay, so now end of the class. So four classes are defined. Coming to the main function, so you have to create an object for last derived class D, and you can call all the member functions because all the member functions are inherited to the class D. Okay, create the object for the derived class D, call all the member function. So these get data belong to class A, and product belong to class B, sum belong to class C, and division belong to class D. So altogether with the one derived object, you can call all the base class function. So this is the simple way of explaining hybrid inheritance working. You can apply the same logic for any real world scenario like banking, which I said in the previous inheritances. Okay, so that is the end of the hybrid inheritance. Thank you.
Hello everyone, welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss inline function in C++. What is the inline function? Inline function is a function for which the compiler attempts to replace the function call with the actual function code during the compilation. It is used to reduce the overhead of normal function call and improve the execution speed for the small functions. What are the advantages in inline functions? Reduces function call overhead, improve the execution speed for small function, useful for frequently called functions. But some are the limitations in the inline functions. The inline function may not work well when the function contains loops or switch or complex logic. The function is recursive and the function size is very large. In such a cases, the compiler may ignore the inline request. What are the difference between normal function and inline function in C++? First start with the definition for the normal function and inline functions. In normal functions, a regular function where the compiler performs a normal function call. In inline functions, a function where the compiler replaces a function call with the function code itself. Next, keywords. there is no special keyword is required in the normal function. But the inline function, it will use the inline keywords. And next, execution. The control transfer to the function and return back after execution in normal function. In inline functions, the function code is inserted at the place of the function call. And next parameter is speed. The normal function is slower because the function call is over here. In inline function, the speed is faster since there is no function call is over here. Next parameter is memory usage. The normal function uses less memory because only one copy of the function exists. Inline function may increase the memory usage because the code is expanded at each call. The normal function is suitable for large and complex functions. The inline function is suitable for small and frequently used functions. The last parameter is compiler decision. In normal functions, always executed as a normal function call. In inline function, the compiler may ignore the inline request if the function is complex. Next, we'll discuss the syntax. In the syntax, the first we will start with the inline keywords, then followed by return type, then function name and parameter. Within the brace, then we will write the implementation code. For example, the sum of two numbers. So here first we will write the function. So inline, the return type is integer, the function name is add. Again there are two parameters, that is a and b. So both are belongs to the integer categories. So here the code is a plus b, the result is finally returned. And then here the main functions, it will invoke the functions. So function name, then followed by two values. The both two values belongs to the integer. Whenever the code is executed here, okay, the compilation is done, automatically the logic here is copied here, then it will return the result instead of calling the function call. So this is the way we are going to save the function call, and then the compiler replace the function call and it will insert the logic directly here and we will get the result immediately. Inline function inside the class. All the functions defined inside the class are automatically treated as an inline function. For example, in this class, so here we are writing one function name inside the class. In these cases, the function is treated as a inline functions. For example, class test and then publish the access specifier, return type is integer, the function name is square and one parameter. The logic is that is square of the values. Then finally the return result is written here. So in the main function, the object is created from the class. With the help of the object, then we are going to invoke the functions. So here automatically the controller goes to the class and then it will invoke the function. The finally the result is come to the main functions, then it will display here. So what is the logic here actually? So any function is returned inside the class, it is treated as a inline functions. And next, inline function is declared inside the class but defined the outside of the class. If the function is declared inside the class and defined the outside, that cases we must explicitly use inline. See the example. So the class is test and then access specifier is public. here the function is declared. For example, return type is integer, function name square, and parameter is x, that is belongs to integer. So here is function is declared and the class is closed. So the function is defined outside of the class. Then how to write the function? How to write the function outside of the class? So here prefix is inline. Explicitly we are writing here. Then integer is a return type. Test is the class name. Then followed by scope resolution operator. Then function name is square. So why we are using scope resolution operator? So we are going to invoke the function from outside of the class. So the class square is belongs to the class name is test. Then the parameter is integer. So here the logic is the square of the number. The final result is written here. So now the operation is closed here. The main functions creating the object from the class. Then with the help of the object we are going to invoke the function with the values. So whenever the program is executed here, automatically the controller goes to the class. So here the function only declared. Again it will search the same function outside of the class, then it will invoke. So then finally calculate the result, then the result is sent to the main program, then it will display here. So what is the function here? Declared function is declared inside the class and defined is the outside the class. That cases we must write inline keyword explicitly. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss friend function in C++. The main concept of the object-oriented programming paradigm are data hiding and data encapsulation. Everyone know the data encapsulation concept. Whenever the data variable are declared in a private category of the class, these members are restricted from accessing by non-member function. It means only the member function allowed to access the private variable. The private data value can be neither read nor written by non-member function. If any attempt is made directly to access these members, the compiler will display an error message as inaccessible data type. So we need a special functions. For in a real life, you will share your private information like your happiness or share whatever to your friend only. It means you will allow only the friend to access your private information. The same concept we are going to apply here. A friend function is a function that is not a member of the class but has permission to access private and protect member of the class. A friend function is declared inside the class using the keyword friend, but it is a defined outside of the class. What are the characteristics of friend function? It is not member of the class. It is declared using a friend keyword. It can access private and protect member of the class. It is called like normal function, not with an object. For example, the class sample. And then here private is the access specifier where declared two variable A and B. It means A and B under the private variable. It means only the member functions only allowed to access the variable A and B here. And next public is another access specifier where we can define the functions or declare the function here. Here sample is the constructor. Already you know the concept of constructor, right? The class name and the constructor name should be same. So constructor name is sample here. Sample here, and then here there are two variables, int x and int y. So the two variable, it will get the value from the main class, and then it will pass us to the class members. So for example, x is assigned to A, y is assigned to B. It means what? Get the input from the main functions and then it will assign to the class variable. And the next one is how to declare the friend function here. Friend is a keyword followed by return type, then function name, and within the parenthesis create a object from the class. Then class is closed. And next one is the say function is defined outside of the class. For example, here no need to mention friend keyword again here. Directly we can mention return type, function name is sum, then creating object from the class as a parameter. So now with the help of the object, then we are going to access the private member of the class here. So for example, s.a and then s.b. S is the object, right? And a is a variable. So now with the help of the object, then we are going to access the private member of the class from outside of the class. So here we are going to access, then we can do any operation here. Then function is closed. So in the main program, so creating the object from the class, same time you are passing the value to the constructor. So you know the constructor concept, right? When the object is created, automatically the value passes to the class members variable. And next, how we are going to invoke the front functions? So function name, and next one is the object as a parameter here. So sum, this is a function name, here object, right, already created. Here object is we are passing as a parameter. Automatically it will control is goes to here, then automatically it will search the same function the outside, then it will invoke, then it will work. Then finally the result is printed here. And next one is the friend is declared using friend keyword. So because here we are going to discuss the friend class. So which allow all the member function of the friend class to access private and protect member of the another class. Friendship is not a mutual unless both class declare each other as a friends. Friendship is not inherited. Just remember these points. For example, so friend class, so we will discuss one example. So now class B, this is a forward declaration. So first we will create one class. Class name is A, and then one variable is declare under the private category. And next one is constructor is defined here. So now we are passing one value to the variable. The next one is we are declaring the class here, that is friend, and then class B. So it means what? B is a friend of A. Then class is closed. Again, we are creating another class B, and then here we are declaring one variable under private category, and then constructor is defined under the public. Here the 20 is assigned to the variable. Again, here we are declaring one methods. For example, void, the method name is add, and then here creating the object from the A class, and then class is closed here. So the same functions is defined from outside the class. So function name return type is void, and then class name is B, scope resolution operator, and then the function name is add. So now the add is belongs to class B. Again, object is created from the A. So with the help of the object only, then we are going to access the private member of the class A. So object.x, and then plus y. So y is that is the member function. So here the local member, right? So now locally we can access directly without using object. So then we can do the operations. So in the main program, object is created from the class. For example, A1 is object created from A class, B1 is another object is created from the B class. So now with the help of the B1 object, then we are going to invoke method add. Again, the A1 is a object is passing as a parameter. So automatically the control is comes to here, then it will invoke this function. Then we will invoke the private member of the class A, then local member of the Y, then we can do the operations. So finally the result is displayed here. Just remember one point. So now the class B is allowed to access private member of the class A, but the class A not allowed to access the private member of the B because only the one-way friendship here. And one more example. So mutually we are going to make the relationship with the class A and the class B friendship. So that cases, so both class to access private member of the variable to each other. So for example, class A. So here variable is declared under private category, and then here constructor, the value is assigned to the variable. Now friend class B. It means B is a friend of A. So here we are declaring one method void add, and then so the class is another class, right? Another class can be creating object, just a declaration, member functions. Next to one more class B, again here we are declaring one variable under private. So here we are creating the one constructor, then values passes to the class variable. And next we are making the friendship, right? Friend class A. It means A is a friend of B. Again we are declaring one more functions void multiplication, and then class name A, that creating object here, and then closed. Then class is closed. That cases A is allowed to access private member of the B. B is also allowed to access private member of the A. So both are mutual friendship between them. So the here the method is defined outside of the class. So for example, void A scope resolution operator, method name is add, then object created prim. So now add is a method belongs to A class. So here X is a local variable, right? Directly we can get. Then Y is the another class variable. So we need object, right? Object dot Y. Automatically we can access with the help of object. Then here we are doing addition operation. And one more method, okay, we are going to define outside of the class. Void class name is B, scope resolution operator. The method name is multiplication. The object is created from A. So here object 1.x. So now X is the another class variable that is a private members. So with the help of object, then we are going to access outside of the class, and Y is the local variable, then we can directly use them. Then we can do the multiplication we are going to display here. In main methods, object is created from A, and one more object B1 is created from B. Then we are going to invoke the methods. For example, A1.add, the B1 is acting as a parameter here. And next to B1 dot multiplication, the A1 object is acting as a parameter here. So that cases both method is invoked and executed. So what is the concept here? So both are mutual, making the relationship between them. So A class is allowed to access private member of the B. Similarly, the B class allowed to access private member of the X. So that case both are accessed. So finally the result will be displayed here. Some other remember point we will discuss that. What is the main advantage of friend function? It reduces the execution time. It allows access private and protect data without making it public. It supports the inheritance. It creates object automatically. Which one is the right here? It will allow to access private and protect data without making it public. And next question, Which of the following is not true about friend functions? There are four options. They can access private members. They are not a member of the class. They are called using an object. They can be declared in any access section. So the answer is they are called using object. And next one, remembering point. If class A is a friend of class B, then the four option is there. Class B automatically become a friend of class A. Class A can access private member of class B. Both class can access each other private members. Neither class can access private member. Just read the question carefully. If the class A is friend of class B, one-way direction, right? So it means what? The class A can access private member of class B. This is correct. What is the primary disadvantage of the friend function here? Actually, four option is given: increase the execution time, violation of data encapsulation, increase the memory usage, multiple inheritance uses. The correct answer is the violation of data encapsulation. Already you know that data encapsulation. So data hiding, right? It means the other class or non-member function is not allowed to access the private member of the variable. But here, with the help of the friend function, then we are going to access the private member of the class. So we are violating the data encapsulation, right? So this is another drawback in the friend functions. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss virtual function and pure virtual function in C++. So what is a virtual function? Virtual function is a member function in the base class, which is overridden in the derived class, and which tell the compiler to perform late binding on this function. Here the virtual keyword is used to make the member function of the base class as a virtual function. It will support runtime polymorphism, that is dynamic binding. This means the function call is resolved at runtime based on the type of object being pointed to, not type of pointer. The syntax base class here, and the next here the public is the access specifier. Here void show is a normal function. In prefix, if you are adding the virtual keyword, the function become the virtual functions. Then within the brace, then we can implement any code here. So here the difference between non-virtual function and virtual functions. How it will invoke the normal virtual function, how it will work in the virtual functions. For example, class base, where we are going to define the function void show. The same function is redefined in the derived class. For example, class derived, then inherit the property from the base class. Again, the same function is redefined in the derived class. In the main functions, here we are creating the pointer variable from the base class, and the object is created from the derived class. Now the pointer variable which hold address of the another object. Now the pointer is pointing to the show. So what will happen here? Automatically it will give the priority in the base class, because the same function is defined both base class and derived class. The compiler, it will get conflicts it, then it will automatically execute only the base class function. So the result is base class. If you want to print the derived class message in the derived functions, so here we are going to make it the base class function as a virtual function. How we are going to make the base class function as a virtual function here? We'll discuss now. So now again the same code here. So now instead of writing only the void show, in prefix we are adding the new keyword virtual. Now automatically the base class functions become the virtual function, and the derived class function is a normal function. So here see the same function is redefined both base class and derived class, but So in the prefix, we are adding the virtual keyword. So now the base class function become virtual function and derived class is a normal function. Now derived class which will override the base class function. So now the pointer variable is created from the base class, derived object is created from the derived class. Now the pointer variable for address of the another object. Now again b dot show. Automatically what will happen? The derived class function override the base class function. So what is the result now? It will print derived class. Then another example. For example, the base class has two functions. One is a vegetable, is a normal functions, and next one is a fruit, is a virtual functions. Again, the derived class, which will inherit the property from the base class, it also has two functions. One is a vegetable, and next one is a fruit. Again, the class is closed. So now the object is created. Now the object is created from the derived class. The pointer variable is created from the base class. The base class pointer whole address of the another object. So now b dot vegetable. So that case what will happen? Here also vegetable is there. In derived class also vegetable is there. So now compiler it will get conflicted. Now automatically the compiler it will execute the base class functions. So now the result is base vegetables. Again control is comes to main function. The next statement is b dot fruits. So now what will happen? Automatically the control is go to here. So now already the base class function is become the virtual function, and then here the derived class has a function. Now the derived class function override the base class function. So what is the result now? Derived fruits here. Actually here previously we used only the dot operator. Here we are using this operator. While using the pointer variable, we are using the operator. Then we are going to access the function here. And next one is a override concept. The derived class provide a new implementation for a virtual function that is already defined in the base class. When a function in the base class is declared as a virtual, the derived class can override it using the same function name and the parameters. This is used in the runtime polymorphism. Just to remember some of the function point, the function name must be same in the both classes. It means both base class and subclasses. Parameters must be the same. Base class function should be the virtual. Override keyword improve the code safety. Some of the example here. For example, class name is shape. So now here we are defining one virtual functions. Again the class rectangle which will inherit the property from shape. So here there are two local variables declared here, and then here one of the constructor which will assign the value to the variable. And next one is we are using the same function that is already void area which is already defined in the super class, that is the base class, right? The same function is redefined here. We are writing on new word that is override. Here we are going to calculate the area of rectangle. Here we are at the same time we are going to display the class is closed. So now the pointer variable created from the shape class and an object is created from the rectangle class. At the same time we are passing the value. Automatically the value is assigned to length and breadth here. So now the pointer variable which hold address of the object. Now the pointer is pointing the area. So automatically the compiler it will execute only the derived class function. It means the derived class function override the base class functions. Even though the name is same, the signature is same. So finally the result will be printed here. And next one is the pure virtual function. The pure virtual function are the virtual function with no definition. They start with virtual keyword and end with 0. The pure virtual function is declared in the base class with 0. It will make the class abstract. It means we can't create the object from the abstract class. And also the pure virtual function must be defined outside of the class definition. Is optional. The next one is a pointer or reference of the base class type can point to derived class object. What are the characteristics of the pure virtual function? It must be overridden by derived classes to create a concrete objects. Class with at least one pure virtual function is an abstract class. It has by implementation in the base class, but still must be overridden. For example, class share, and then we are declaring the object that is a pure virtual function. So for example, virtual return type function name equals 0. So automatically the function declaration is become the pure virtual functions because the virtual keyword is there and the class is closed. The same function is used in the derived classes. For example, one derived class name is rectangle. In here the property from the shape. Here there are two variables declared length and width here, and then the same function we are using here void area, and then we are using the override. So here we are calculating the rectangle, then close it. And next one is the one more new derived class circle, which is in here the property from shape. Here I am declaring the one variable radius, then we are calculating the area of the circle using the formula. So now class is closed. So now here the pointer variable is created from the shape, and then one more object that is a R is created from the rectangle, and then one more object C is created from the circle. So now the S1 hold address of R. It means the pointer, it will point to the rectangle object. So now S1 dot area means what? Automatically the control is come to here. So the rectangle, the function override the superclass. So now it will execute here, it will print the rectangle area. Again control is come to main function. The pointer is point to the circle object, address of the circle object. Now S1 dot area mean the control is come to here because the pointer hold the address of the circle object, right? S1 dot area mean automatically the control is come to here. The circle functions which will override the save functions. So now it will execute here only, then it will print the circle area. So this is the way we are going to implement the pure virtual function. And next one is the pure virtual function is a virtual function that has no implementation the class declaration and is assigned to 0. It is used to make the class abstract and force to derived class to provide their own implementation. The pure virtual function definition is useful when all the child will have the certain common behavior to the implementer. So here the concept is the virtual function, that is a function is declared in the base class, the same function is defined the outside of the class. Again the same function we are used in the derived class. Okay, so now the pointer is created from the base class, and the object is created from the derived class, the pointer which hold address of the object, and then p dot display. So here also display, here also display, right? Even though it is defined outside of the class or the derived class function, it will override the superclass function. So what is the result here? So once override I mean automatically, so the control here only, then it will print the derived class. Just remember some other point in the virtual functions. Declared using the virtual keyword, it is used to achieve runtime polymorphism. It will support dynamic binding, that is layered binding, and called through the base class pointer or reference, can have definition in the base class. Overriding the derived class is the optional. Class with the virtual function is called polymorphic class. Constructor cannot be virtual. The destructor can and should be virtual in the polymorphic base classes. Some of the points just remembering in the pure virtual function. Here declared by assigning 0, it is used to achieve the abstraction. forces derived class to provide the implementation. A class containing at least one pure virtual functions become the abstract class. So here it's not possible to create the object from the abstract class. So the pure virtual function may have defined outside of the class also. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss abstract class and interface in C++. What is the abstract class? Abstract class is a class that cannot be instantiated. It means cannot create an object. And it is used as a base class for other classes. The abstract class must have at least one pure virtual function. A pure virtual function is declared using equal 0. The abstract class are mainly used for inheritance. The derived class must override the pure virtual function. If the derived class does not implement pure virtual function, it will also become an abstract class. The syntax here, class name, and then access where here declared the pure virtual functions. So the class become abstract class. Example, class shape, it has the data member string s equal shape class. And it also has one normal function definition where we are going to display the value of the x. Then followed by pure virtual functions. So the class has data members, normal function definition, as well as pure virtual function. So the class become abstract class because it has at least one pure virtual functions. And next one is there are two derived class, for a class rectangle and a class circle, which is inherit the property from the superclasses. So the rectangle class, it has data members, for example length and width. So the value length of the value equal 10 and the value of the width equal 5. Again next one, the method void area, which is already declared in the superclasses. So now here we are going to calculate the area of the rectangle, length into width. This is a formula. Then class is closed. And next one is we are creating one more subclass circle, which is negate the property from superclass shape. It has the properties, for example int radius equal 4, and it has the method void area. So here we are going to call the area of the circle. So the method name already it is declared in the superclasses and the class is closed. In the main program, we are creating the object from the derived class. There are two derived class, rectangle and the circle. So the object R, which is created from the rectangle, and next to object C, which is created from the circle. So with the help of the subclasses object, we can access both superclass property as well as subclass property. So here R.display, automatically the control is come to here, then it will display the value of the x. What is the value of the x? Shape class. Again controls come to the main program, then R.area, automatically it will go to the rectangle functions. So now the rectangle function, it will override this superclass. So automatically it will execute in this code, then we will get the result. That is area of the rectangle equal 50. Then again controls come to the main program, then C.display. So the C is which is belongs to the circle. So now C.display means what? It will go to the superclass, it will print the value of the x. What is the value of the x here? Shape class. Again the control is comes to the main program and then C.area. So now automatically it will invoke the class functions, class circle functions, void area. So now it will override the superclass and then here it will code will be executed here. Then we will get the result. The next concept, interface. The interface is the class that contain only the pure virtual functions and no data members. It is used to define a common set of functions that derived class must implement. The C++ does not have any separate keyword called interface. Instead of, it is implemented using the abstract class with only the pure virtual function. Object cannot be created for interface. The class must implement all the function of the interfaces. Class means derived class. It is used to achieve 100% abstraction. So for example, the class has only the pure virtual function. So the class become an interface. This class shape, so it has only the pure virtual function declaration here. So the class become interface. The same function name is implemented in the derived classes. For example, rectangle and the circle. There are two derived classes. So the derived class has one data members, length equal 10, width equal 5. So here the wide area. So now here we are going to calculate the area of the rectangle. Then we are going to display here. So now this area, wide area, it will override the superclass. Again, one more subclasses, circle. It also has one data members, radius equal 4. And also it has void area as a function where we are going to calculate the area of this circle. Formula equal 3.14 into r square. So now this area also override the superclass functions. The main program, we are creating object from the subclasses. So for example, R is the object which is created from the rectangle and C is the object which is created from the circle. So R dot area means automatically it will invoke the area of the rectangle. So this area, it will override the superclass. Then it will execute the code here, then we'll get the result. Similarly, C dot area, then automatically it will come to the class circle functions, wide area. This area also override the superclass function. The code is executed here, we will get the result, the area of the circle. What is the difference between abstract class and the interface? First start with the definition. The abstract class is a class that contains at least one pure virtual functions. The interface is a class that contains only the pure virtual functions. In abstract class, the function have both normal function and pure virtual function. In interface, it has only the pure virtual functions. So in abstract class, a data member is allowed. In interface, a data member is not allowed. Object creation, both abstract class and interface not allowed to create the object. And next one is the implementation. Some of the function can implement in the abstract class, but there is no implementation in the interface, only the function declaration. What is the purpose of abstract class? Used for partial abstraction. But interface is a complete abstraction, that is 100%. Some of the point, just remember that to differentiate the different type of classes. For example, the class has the private data members and normal function is a normal class. And then how to identify the front class? For example, class has data members and then parameters and then constructor or functions as well as the front. If you are identifying the front keyword, so the class becomes the front class. Next one is the abstract class. Then how to identify the abstract class? The class has data member, normal function definition, and also at least one pure virtual function. So this cases the class become abstract class. Then how the interface differentiate from the abstract class? The class has only the pure virtual function, the class become the interface. So what is the difference here in abstract class and interface? Abstract class, it will allow data members, normal function implementation, at least one pure virtual function. But the interface, it will allow only the pure virtual function. It not allow any data members. It not allow any normal function definition. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss UML state chart diagram. What is a UML state chart diagram? The UML state chart diagram, also called state machine diagram, it is used to represent the dynamic behavior of the system. It shows how the object changes its state in response to the event over a time. The state diagram describes the flow of the control from one state to another state. Before drawing a state diagram, we should clarify the following point. First, identify the important objects to be analyzed. Next, identify the states, and next, identify the events. And next, component of the state diagram. So there are different components used here. First state, a condition during the life on objects. It is represented by a rounded rectangle. And next one is the initial state. It will show that the starting point of the system. It is represented by a filled circle. And next one is the final state. It shows the end of the system. That is the final stage. It is represented by circle with dot inside. It means it looks like some eyeball. And next one is the transition. It is movement from one state to another. It is represented by arrow marks. Next one is the event, something that happened to trigger the transition. Example, button press and timeout. The next component, action, that is activity performed during the transition. The next component, 4, the incoming arrow from the parent state and outgoing arrows towards the newly created states. The fork notation to represent the state splitting into two or more concurrent states. See here, the single input and then split it into two or more output. And next one is the joining. The incoming arrows from joining states and outgoing arrow towards the common goal state. For example, see, it will get the input from more than one state and it will pass us a single output to the final goal state. And next one is the self transition. The solid arrow pointing back to the state itself to represent the self transition. And next one, composite state. The rounded rectangle to represent a composite state also. It represents the state with the internal activity using the composite state. We will see one example diagram. For example, state machine diagram for ATM system. First, start with the initial state, then it will go to the first state, read the code. If the code is valid, then it will move to the next state. What is the next state here? Read the pin code. Suppose the card is invalid, then it will go to the final state, that is eject the card. Again, read the pin number. If it is valid, then it will go to the next state. If it is invalid, then it will go to the final state, eject card. If it is valid, then we can choose the transaction. Once choose the transaction, it will go to the next state and perform the transaction. Again, it will ask whether to continue the operation or not. Then we can continue any other transaction. If not, the transaction is over. Again, finally, automatically it will go to the final state and eject the card. It will go to the final state here. And next, what are the advantages of UML state chart diagram? modeling the dynamic behavior clearly and show the object life cycle, and it will help to identify the valid and invalid states and improve the system understanding, and it is useful for event-driven system. Thank you. So everyone, welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss UML activity diagram. So the activity diagram is a UML behavior diagram. It shows the sequence of action or the flow of control in a system. It is like to the flow chart or flow diagram. It is frequently used in the business process modeling. The model activity are either sequential or concurrent. Next one is the component of the activity diagram. So there are different type of component are used here. We'll discuss one by one. First one is initial state or starting point. It represents the initial action state or starting point of the activity. It is represented by a small filled circle followed by an arrow. So see the symbol. And next one is the activity. It is used to illustrate the set of action. It shows the action of the objects. It is represented by the rounded rectangle. And next one is the action flow. It is also called edge and paths. It shows the switching from one action to another. It is represented an arrow line. And next component, object flow. The object flow refers to the creation and modification of object by activities. The object flow arrow from action to object means that the action creates the object. The object flow arrow from object to action, it will indicate that the action state use the object. And next state is that is a synchronization. So the fork node, it is used to split the single incoming flow into multiple concurrent flows. It is represented as straight and slightly thicker line in the activity diagram. See here, this is a fork node. So it will get the single output and split it into number of concurrent flows. And next one is the join node. It will join the multiple concurrent flows into single outgoing flows. See here, it will get the input from more number of activities, then it will combine, then it will put the single outgoing flows. The next component, decision and branching. A diamond represents the decision with the alternate path. The next component, merge node. It represents the merging of the flows with several input and only one output. See here, it will represent the merging all the input and then it will produce single output. Signal sending represent the sending a signal to accepting activity. And the signal receipt, it means represent that the activity has received the signal. The next component, time event. This refers to event that stop the flow of the time. And the next one is command. It is used to add the commands to the elements. And next component, final state or endpoint. It shows the final action state. It is represented by arrow pointing to filled circle nested inside another circle. Look like some eyeball. And swimlane. The swimlane groups the related activity into one column. We will see one example for activity diagram. So here we will take one example, ATM machine actions. So here the entire activity we are going to group using the swimlane. So for example, customer is this group of activities, and the ATM machine some of the group of activities, and the bank some of the group of activities.
we are going to divide them. We are going to separate the actions. So for example, first initiate the operation. The customer, they will insert the ATM card. Again, the ATM machine, it will verify it is valid card or not. If it is valid card, it will show this, enter the PIN number. The customer, they will enter the PIN number. Again, the PIN number is verified in the bank. If it is valid PIN number, then it will show that enter the amount. If it is not valid PIN number, it will go to the exit state. Again, the customer, they will enter the amount. The amount is verifying whether it has sufficient balance or not. It has a sufficient balance, then it will go to the debit account. The same time, we will get the cash. So after completion, after getting the cash, it will come to here. Then debit state also it will come. Both are joined. Then it will produce one state. And next one is after that, then it will display the balance. Then it will go to the next state, that is eject the card. And then finally it will go to the next activity, get the ATM card. Then finally it will connect it with the final stage of the action. What are the advantage of UML activity diagram? It is easy to understand. It will represent the workflow clearly. It supports parallel activities. It will help to identify the bottlenecks. It is useful for business process modeling. Thank you.